Hello, everyone. Great to be here. And for you today, I have crafted a special talk, and I'm just going to read the title to you. So Sentient clusters, microservices on the Docker swarm. Can you count how many buzzwords I put in the title? It's like I tried to squeeze as many I could. I think I did a good job. The point of this talk is to give you a sense for, there is this huge trend of going to, a small, loosely coupled services deployed in the cloud. And it's a theme that fits fantastically well with, embracing Atlassian Connect, where you can build your own infrastructure and choose your own technology stacks. So I thought it would be interesting to see what the landscape offers, what actually Docker's tool offer in the orchestration arena, and work you through an example together from start to finish, and then take some learnings of how this can be applied as you develop and embrace Atlassian Connect in our ecosystem. Well, we talked specifically about Docker today. And Docker and what the Docker ecosystem offers to you. So if you have been sleeping under a rock, you have missed the revolution, which is like in the past 3 years, our global consciousness, tech consciousness, has shifted a little bit in thinking how we want to assemble our applications when we deploy them to the cloud. And so it's not that we couldn't package and deploy applications before. It's just that a consensus gathered and gained a lot of momentum in the last couple of years. And so what Docker did was to give us a way to package application, a standard way to package our application, a way to define clear interfaces of how our services will talk to the outside world. Docker gave us a caching layer so that we could build our application incrementally and reuse the steps in our builds that can be reused. And gave us another way to centralize and store all the deliverables. We've been using for years the Artifactories of the world, the Nexuses of the world, where we would deploy and store our jars. And nowadays, you can do a similar thing by using a Docker registry, and you're not tied to a single technology, but you can package any sort of applications. So that was well and nice, and the industry became very excited about the potential of Docker. And then in the past year and a half, there has been an explosion of moving this to a higher level of abstraction and trying to simplify the work for the average software team. And so what has come about has been orchestration frameworks. So once you are able to run your applications inside containers, the developers can stop worrying about the lower-level physical infrastructure and let an orchestration framework actually deploy the workloads and the containers onto the physical machines. The only thing that's left to us as developers is define developers and DevOps developers, DevOps engineers, is to define the relationships between our application, the services of our application. So if you think about it, and this is connected with what you can do with these sort of technologies and Atlassian Connect, is if you start moving your infrastructure to small, loosely coupled services, they become much easier to upgrade in isolation, and they become easier to reason about if you can define how the services in your stack relate to each other at a much higher level. And these orchestration frameworks that take care of managing your physical infrastructure have a scaling and high availability embedded in them. And this is a big win for, the average developer doesn't really think about, or is not, you need especially skilled people to think about massive scale. So those frameworks can help there. Now, I was thinking, let's not keep this too theoretical. Let's do something practical together. So what I'd like to do with you today is pick a sample application, like based on a polyglot application. See, I used another buzzword, polyglot application. There's different technologies in different parts of the application. And let's start from scratch, like deploy infrastructure, build infrastructure, and deploy it on a cluster together. Now, I see you, some of you, this is your level of interest. Some of you is like that. But some of you are overexcited. So I hope there will be interesting things for both of these categories. Now, a caveat about what I'm about to show you, because this is just a half an hour presentation, and I had to compress a few things, go skim over a few of the concerns, and some of the ops guys in the back we will talk about that later. I had to skip a couple of things, and we can talk about them later. So what I want to show you is pick a sample application, which you might have seen is maybe trying Docker Compose demos. It's a voting application, but we will deploy it all automatically on a full cluster, and it will be beautiful. So the application is a voting platform. There's a specific subdomain to vote on things, very complicated, cats and dogs. And there will be an application where you will collect the results, read the results. So you could have done this in a central way, just like a monolithic application, just a front end and a back end and a database, and be done with it. But we want to do this the modern way, in microservices, making sure that we can scale infinitely and maybe leave things to every specific part of your application, leave it to a different team, free to choose its own technologies. And in connection with embracing Atlassian Connect, as you develop and integrate in the platform, you can choose and develop your services in any kind of technologies. So this is how I imagine this application will build together, will look like. We'll need a proxy at the front. Can I use the pointer? I just switched it off. Sorry about that. So you will have, at the front of the application, a reverse proxy, a load balancer. The users that want to vote will go to the voting application. The voting application needs to respond and store votes really quickly. So it will store the votes temporarily into Redis key value store. And then we'll have a worker written in Java that will copy those votes from the key value store and stores them into a Postgres database. And actually, the actual results of the voting will be served from Node.js application, and the reverse proxy will serve traffic to the Node application itself beautifully. So this is the architecture that I had in mind. Now, if we have to deploy all this from scratch, we need a few pieces of infrastructure to make it happen. And this is where I show you where the Docker ecosystem provides you the tools to do this the right way. The first thing we need is we need something to provision machines, so like create machines that can run Docker and where our services can run, and hopefully done this as automatically as possible. So to do this, we'll use a Docker machine. Also, Docker machine allows you to provision machines not only that run Docker containers, but also that can make themselves aware to a cluster, a signal when they're up or down to the discovery service, which we'll need. Next, we need something. This is where we talk at a high level how the services in our application are related to each other, which ports should be open, which service should access which other service. And for that, we'll use Docker Compose and a configuration language that Docker Compose uses. Third, we need a cluster manager. The cluster manager in the Docker's own ecosystem is the Docker Swarm. It keeps track of which machines are part of a cluster. It can deploy application services to containers on a cluster following some business rules like filters and affinities. And I'll tell you much more in detail what we can do with that later. And as a side, at the side of all this, you need some cross concerns that will need to be there for everything to work. For example, if you have different machines running on different data centers, they need to be part of the same network for the machines to be able to talk to each other. We can do that using Docker Network, which is now a first-class command of the Docker ecosystem. And you will need, eventually you'll need volumes, cross-cluster volumes, and other concerns. For example, other things we need a way to distribute load across all the services that want to respond to certain subdomains. We need a way to manage distributed logging. Some of these things I'll cover, some of these things I will elegantly gloss over. And so From the physical infrastructure point of view, just what we'll need, well, a cluster manager, which I call here a swarm master. I'll give you a bit more detail just in a bit. A discovery service that keeps the pace of which machines are part of the cluster. Then we need a reverse proxy machine that will handle all the front traffic of our application. Then one or more machines allocated for the services, the Node.js application, the Python application, the workers, and that we can scale out as much as we need. And maybe it's slightly different kind of machines where we'll beefier with a bigger hard drive, faster, bigger disks to handle database loads. Once we have all this, obviously we'd like the swarm manager, the cluster manager, to be able to deploy and manipulate things that are happening on those other machines. So in fact, what I want to give you is a word about Docker Swarm for people that haven't played with it or haven't heard of it before. It is the cluster manager built by the Docker team, by the Docker open source team. And the architecture of Docker Swarm is more or less this one. There is a master called the Swarm master, which can be a redundant master, which has a scheduler inside that can deploy workloads on Swarm nodes. Now, the Swarm master, to know which machines are part of a cluster, it uses a discovery service, which is pluggable. So there's quite a few discovery services nowadays available and popular. There's etcd, there's Consul. In this specific example, I will use Consul, who is a discovery tool, and also key value store to keep track. For example, it allows you to keep track of the machines that are part of a cluster. And the beautiful thing about this is that the provisioning tool that we'll use, Docker Machine, can make use of Consul out of the box. So we start from scratch. We want to create the machines that we will use to build this infrastructure. To provision the machines that can run any application packaged with Docker, we can use Docker Machine. So Docker Machine is a command line tool that has support or drivers for a vast number of interfaces as service providers. And so if you have already an Amazon account, you can use Docker Machine to create hosts on Amazon. If you use the Google Cloud, you can use the Google Cloud, Rackspace, DigitalOcean, Microsoft Azure. Docker Machine supports all of those and more. The way it works is relatively simple. When you want to create a machine, you type Docker Machine, create. You specify the driver, which you should read the provider that you want to use. You can even create machines locally if you want. And then you have to pass a few parameters. So in this example, I was using a DigitalOcean account. So I need to pass my authentication key. I need to specify on which region I want the machine to be created. And I have to give it a name. This goes onto the provider, creates the machine with Docker installed, ready for me to run Docker commands on it right away. But we want to create a cluster-ready machine, a machine that knows where to advertise itself to the discovery services so that the cluster manager, Docker Swarm, can deploy workloads to it. So the commands to use Docker Machine to create a machine that's part of a cluster is a bit long. Obviously, you can script all of it. I'll show you how I did that. But the important flags are you need to add a flag that says I'm part of a swarm. I add -- swarm. I need to add, if it's the swarm master, which in this case I was creating the swarm master, I added the -- swarm master. And then you need to tell, as you create it, to Docker Machine, where's the discovery service. So all those 3 parameters that you see at the bottom are the flags you need to pass to the Docker Machine so that the machine can advertise itself when it comes up and when it goes down. Now, just to show you that I'm not cheating, we'll just switch to, so that you can guys see. So I've created, actually scripted out all the Docker Machine creation steps. So I create Consul, so I create the machine that runs the discovery service. I started the discovery service, and then I create the cluster manager. The only thing I want to highlight, I'm just going to quickly scroll through the file just to show you that We've been doing this, we do this together. The only thing important at this phase of the creation is that we can label the machines with some labels. So for example, the reverse proxy, I'm going to just label it rproxy, so that then later when I deploy workloads on it, I can reuse that tag without worrying about where the machine is or which IP address the machine has. So I'm labeling this machine for service workloads, and if I run this script, this will go on DigitalOcean and start creating the machines. Now, because we only have half an hour, I have sped up a little bit this video. And otherwise, it would take a few minutes. Depending on the infrastructure and the machines and the providers, this might take more or less time. So just to speed through it. And after this is done, we should have 5 machines created ready, part of our cluster. So I see that a little bit of the screen. Oh, the screen is not cut. That's nice. So if I get to the end of it and I just ask Docker machines, OK, show me all the machines I've created, you'll see I have created, I just hide a few ones because I have a few more. You see I've created 5 machines. 4 are part of a cluster. 1 is not. And 1 is a reverse proxy. 1 is a database, and so on. And if I can now switch my Docker local command to give commands to the entire Swarm cluster by evaluating a couple of environment variables. And then if I type docker info, you'll see that I now have, maybe it's hard to see, but I have 4 nodes available to me now to deploy applications on it. You don't have to get caught up too much in it because I have overview slides to review this. So in the end, at the end of all this creation, I have created 5 machines. 1 is the discovery service. 1 is the cluster manager, the database reverse proxy. And now you'll see it at command line, and you think, yes, but I see only like text. But this actually happened. If you go into the DigitalOcean UI, you just see that those machines are there, and I'm billed by the minute for running them. And the physical chart of what we just did is what I showed you before. So just so that you see it a few times and you get familiar with it. Now here's when, once this all is configured, this is where the beauty happens, the magic happens. And because now we can use Docker Swarm and define the rules on how to deploy our services at a fairly high level, conceptual level. So now we can tell Docker Swarm, first we can decide which strategy to use to deploy our applications onto this cluster. And we can tell Docker Swarm to use a spread strategy. That means use as many machines as possible, spread the load of all these applications, all these services across as many machines as possible. And we can use a bin pack strategy that says, actually, I want to conserve resources. Please try to squeeze as much computing power as possible on as little number of machines as possible. I can also use a random strategy. And then I can use filters to tell Docker Swarm how or where or when to deploy services. For example, I can say, I only want to run this application where an SSD is available because it's a performance-intensive application. Or I only want to run this login service and use an affinity filter. It says I only want to run this login service on the same machine where this web application it needs to log is running. Otherwise, it doesn't make sense to run this login service. So you can give business rules and at a high level of where you want these workloads to happen. So with all these techniques, with these filters and affinities, now we have all the tools to run a configuration that will deploy the reverse proxy, Nginx, onto the reverse proxy machine. The Node.js application for the results on one or more of the services boxes, the Python application, the voting application on a service machine, the Java worker also in there. And we would like automatically to deploy the Postgres database onto the database machine, properly linked and configured to all of that. There is one bit missing, obviously, to make all of this work, where I need to write some configuration where I explain how all these services should be tied together. So we need to link all of these services together in some kind of configuration. And we do that using another tool in the Docker orchestration toolbox called Docker Compose. Docker Compose is a command line tool and a format of configuration file based on YAML. Very similar, very simple, very easy to read and structured, that allows you to define how the services in your application are related to each other. And now to make all this demo application work, we need to go through, and I want to show you how you define them. And it's relatively readable, and I can see you giggling in excitement because you want to see how that's done. I know it's wishful thinking, but I like to think that you're giggling. You're not giggling. But OK, so when defining the services is just a simple single file where you define your services. This is version 2 of the Docker Compose configuration. So as you can see, I have defined a voting application. I specify the image where I have packaged the release I want to deploy of the voting application. I specify which ports with the voting application expose, and on which images it depends on. So the latest version of Docker Compose now you can specify on which services you are depending on. So in this case, the voting application depends on Redis. And at the bottom in the environment variables area, you can specify those filters and affinities that I mentioned Docker Swarm supports. So we can specify that the voting application should run on an instance that we tagged for services. So that instance equals service you see there. We also define an environment variable, virtual host, which is the one that we use from the reverse proxy, so that the reverse proxy will direct traffic to this specific service. I'll explain you a bit more about that in a second. So for the result application, it's very similar, only that the result application will read information from the databases, so it depends on the database instead than on Redis, and it has a different virtual host, results.cluster.local, and we still want to deploy it to the services box. Now, the worker is very simple. It actually needs access to both the Redis instance and the database, and it's a very simple Java application that copies the data, and I also want to deploy it on the service box. And these are plain vanilla images for the database. So I have defined a default Redis image running on its default port, and the Postgres database. Also, the only thing specifically that I wrote here is that it needs to run. In this case, I've been more specific. I want this to run on the database that I called DB, so on the node DB, because it's a special machine that has more disk, and so I can be, if I want, more specific. There is one missing bit from all this configuration I showed you, which is how do I configure the reverse proxy? The reverse proxy needs to see all the applications coming up and maybe multiple versions, multiple instances of their applications, and start directing traffic dynamically to those applications. So to do that, we can use a project called Nginx Proxy. And what Nginx Proxy does, it does monitor the streaming of events from the Docker Swarm cluster. And whenever a container comes up, it checks, does it have a virtual host environment variable? If it does have a virtual host environment variable, Nginx configuration will be reloaded, the list of upstreams will be updated, and it will start serving traffic. Now, there is a gotcha here, is that you cannot run commands inside the Docker Compose file. So we want to dynamically tell the Nginx proxy where is the swarm master. So for that, in that specific case, I load an environment variable file, which we can then generate automatically. I'll just skip this video, otherwise it gets too complicated. But I've shown you enough configuration in the screen. I can see it in your eyes. I know you're ready for it. I know what you're all thinking. You're thinking, where's the demo? Lebowski. And now I imagine you that if I don't show you the demo, this is what you guys are going to do to me. So let's do it together. So after all this setup, it's a little bit anticlimactic what's going to happen, because I'm just going to say Docker Compose, bring up the services, and send them in the background. So Docker Compose up -d. This is going to pull all the applications that I have on the registry. We have an internal registry at Atlassian, dockeratlassian.io. And the Docker swarm is going to deploy those services according to the rules we've decided. So I do Docker PS. You see I have all the pieces of the architecture running. Now, if things are correct, we should be able to go to vote.cluster.local, which I added to my host file, and I should be able to vote on an option. And you can see in the logs that the votes are coming in, that the different services are running. Now, this aggregates the logs from all the services. And if I go to the results application, I should see that there's some options. Now, let me show you that I'm not cheating, that if I actually create an anonymous session and vote for the other option, the vote will be registered. And I vote for the other option. OK, and at least 2 votes were registered correctly. Now, you see a lot of polling there because the results application uses a socket I/O polling mechanism. Now, the thing I wanted to show you is that if we did things right, all the services should be deployed onto the services machine. So the node application, you see, has been deployed on the machines that we tagged for services. The Python application also runs on the services machine, and the database application runs on the Postgres runs on the database machine, and so on. So it seems that our compose configuration and the cluster has received the hints correctly and has deployed our infrastructure in the right place. Magic. So now, this is nice and interesting, and you can see how you just define this high-level configuration file, and automatically, the cluster manager deploys your application in the right place in your infrastructure. And what about scaling? So I told you that these orchestration frameworks allow you to scale up and handle high availability in a slightly easier way than we're used to. Is that true? So let me show you how that would work if we scale up the application. So how hard it would be to scale up. Now imagine the results are being hammered. The results application, everybody wants to see who has won the European Song Contest, or like this fantastic poll about cats and dogs. So we need to scale up. So let's create a new machine, a new services machine. So I type Docker machine create. I specify a region. I specify that it's part of a swarm. And I create it on DigitalOcean as I created the other ones, because we want to scale our services infrastructure by one machine. So this goes out to DigitalOcean, provisions any immediate new machines, and advertises the machine onto console. And now, if I want to scale, just to show you that I have a new machine available, it's called the services 2. It's a different IP address, still part of a cluster. Now, Docker Swarm knows that this machine is part of a cluster, so we can deploy workloads onto it as we did with the other ones. So if I now want to scale one of the applications, for example, I can type Docker compose scale. Wait, I made a small typo. Scale, result application. Maybe we need, let's say I need 4 more instances of this, spread out across all my services instances. And this will create 4 more instances of the result application. Hopefully, they've been spread out uniformly including onto the new machine. And in fact, I can see that the Node.js result application now is running. There's a few more instances running, and they're running on the new machine. Now, just to show you that I'm not, this is just not some text showing up, we can just pick this new IP address at that port and see that the result application is actually running on this, newly provisioned machine. So as you can see, once the logic, the high-level relationship of your application is properly configured, you can scale up relatively easily. There's a lot more to show, but I see that I'm running out of time. So I have just a few closing words of how is this interesting for us as Atlassian enthusiasts. Well, there's many ways how this is relevant to us. One is as you move your architecture towards microservices, you've just seen pipelines announced. So you're fit right in. You can define the container that will test your application and test it in pipelines. So that's one of the things that you can do. The other thing is, as you're free to build and choose your own infrastructure to develop in the Connect ecosystem, Connect platform, you can embrace this sort of architectures to be free to scale up and scale out easily. I wouldn't say easily, but an easier path to scaling if you embrace these sort of architectures. And I want to also, closing thoughts for you, there's many vendors, many experts here that have already been embracing and experimenting and adopting these sort of architectures, maybe not specifically Docker Swarm, but for sure experimenting and adopting Docker containers in production at scale. So I can point you to a few of them here in the audience, but I encourage you to check and talk to each other, because best practices will emerge, and it will help us move forward and be more lean and improve our ecosystem. So that's all I have for you today. Thank you very much. Thank you.